you guys doing? I'm doing good. I feel so much better. I am actually still sick, but I feel like 90% better. Everything is just on the up. So I was inspired to make this video because I've been doing a lot of extra studying this summer because I don't want to fall behind in physics. And I thought that it would be really nice to do just a review of Introductory Physics Part 1, which is what I took this past spring. Physics is something that I really enjoy, as you probably know if you watch these videos. I just thought I would do a review of advice or my first impressions and my introduction into the physics world. There's actually quite a lot to learn in introductory physics, and it often feels overwhelming. It definitely did for me. The thing about physics is that little concepts build on each other and build and build and build until you have like all this stuff. And everything at the top is pretty much based on the foundations way at the bottom. There's a lot of little tips and tricks that I learned along the way that made it really a lot easier than I thought it would be, and definitely a lot of studying and going to study sessions, meeting with professors, reading the textbook, doing the homework. All of those things help in strengthening this foundation in physics. So introductory physics is usually separated into two separate classes. I think it's pretty much the same at all universities. So usually you'll start out with kinematics. It starts out with like speed and velocity and all of that kind of stuff. This can lead students, and it did me, into a false sense of security because it starts on these really easy things, and when you realize how easy it is, you just think, if this whole class is like this, it's just going to be a breeze. Definitely the right mindset. One thing I really loved about kinematics was learning how to use and manipulate the kinematic formulas. Very simply, the kinematic equations help us understand motion at constant acceleration. A lot of professors will make this really complicated because there's like this list of formulas, and these formulas are like the key to understanding like a lot of stuff. And physics professors will tell you have to memorize them, memorize the circumstances under which you'll use each equation. And while this is true and it's very, very useful to memorize them and the different situations you should learn them in, there's a different technique that I learned that makes it very simple. It's kind of like an elimination process, and that's called the SUVAT method. I probably, maybe in the future, will do a separate video on that because it's really interesting, and actually the SUVAT method is what helped me get an A on my first exam. Okay, so the second half of introductory physics is dynamics, and this is where Newton's equations come in. You've probably heard of Newton's equations even if you've never taken a physics class. Introductory physics gets just a little bit more complicated with dynamics. There's two very important things to remember when solving equations using Newton's laws. It's super important to draw a free body diagram, and this is because it helps visualize each force and the direction that it's going. And it's also very important to make a table with all the known forces. So the second part, the table, a lot of professors don't teach this. They're so used to these equations, they just see them in their head, and they're just so used to like grinding out these equations. As an introductory student, that can feel overwhelming trying to keep track of everything in your head. So writing down all of the different forces that are used is definitely something that really helped me. So I went back into my old physics note. On the note card it just says Newton's second law problems, and the tips for it says draw a free body diagram. In that diagram you'll include the axis and all forces touching the object, and then you're going to make a force table of all forces, and those will include magnitude and components. Okay, so using Newton's second law, you can see that I have the word problem written down right here, and then I just have like a reminder that force equals mass times acceleration, and then I drew a picture, so that's the object, and then I put all the forces, and then there's my axis. And then what I did next is I came down here and I made a table of all the forces. So you have weight, and then I wrote down what I knew about it, and then normal force, and then what I knew about it, and then I have friction, and then you can see where I solved all that. And so what you'll do is you'll just use the table to solve for everything dealing with the forces. Once you know all this, you can solve for whatever you're looking for. In this case, I was looking for acceleration, so you can see where I used the equation way at the top. I came back down, and I used everything I knew from the force table to solve for acceleration. So that is how those two huge tips are pretty much the key to solving equations using Newton's laws. Okay, so I know I could have made like a separate tutorial video for that. Sorry if this video is a little bit long, but I just really enjoy talking about this. Introductory physics will also include energy, which you'll talk about kinetic energy and potential energy and the difference between those. I really like learning about kinetic energy There's a lot of different equations to use there as well. Oh, okay, so in introductory physics, we also learn about momentum, and that's super fun. There's something we did in one of my physics labs that dealt with this, where we used hockey pucks, and we recorded the collisions of the hockey pucks, and it was super fun. So in conclusion, there is a lot that is to be learned in introductory physics, but it's all really fun stuff. It can be a little bit complicated. Taking a lab at the same time as a lecture is a great idea. Everything you learn in lecture is complemented in the lab. So if you're learning about momentum, you'll do a momentum related experiment. If you're learning about Newton's laws, you're going to do an experiment based on each of those laws, probably. It's just really fun. So that's like a small review, tips, insights into my experience with intro physics. I'm no expert, I'm just some undergrad student. But yeah, if you have any like physics comments, talks, questions, I'll answer them if I can. And I always love comments, obviously. And thank you to everyone who's been watching my videos regularly. I know there's a few of you out there because I get comments from the same people, and I love you all. And thanks for watching. I'll be back with another video next week because apparently I'm doing like a weekly thing. Bye guys.